Hi, today we're going to be talking about relations and functions. So we're going to go ahead and analyze relations and functions, and we're going to use some equations of relations and functions. So we need to go ahead and talk about what a relation and a function is. Let's start with the easy one, the relation. The relation is a set of ordered pairs. Here's a set of 3 ordered pairs. Now a relation can be 2 ordered pairs, 10 ordered pairs. It doesn't matter how many ordered pairs. This is just one of them. 4, 3, 2, 1, and 0, 4. Remember, the first one is your x value. The second one is your y value. It goes alphabetical, x, y. This is how much we go over and across from the origin, and this is how much up and down. So left to right and up and down for our x and our y. Now with the relation, we have something called the domain and range. The domain is the list of all the x values. So for this example up here, our list is 0, 2, and 4. The range is a list of all the y values, 1, 3, and 4. Notice how I did that? I did no repeats and I put them in order from least to greatest. So for the x values, I didn't just go 4 to 0. I actually went backwards, 0 to 4, so that they would be in order from least to greatest. Now there are no repeats here, but if there was, we would just exclude one of the values. So we don't have to put 2 on there twice. What the domain is saying is these are all the possible x values. When I look at an ordered pair, I should see more than just x and y. I should see an input with an output. So if I input 4 into some sort of equation, I'm getting 3 as an answer. If I'm putting 2 in, I get 1 as an answer. If I put 0 in, I get 4 as an answer. So the domain is all the numbers I can put in. The range is all the answers I get. The 1, the 3, the 4. All right, so what is a function? A function is a special type of relation where the x value has only one y value. Every input, like the 4, the 2, and the 0, has only an answer of only one output. The 4 has an output of 3. The 2 has an output of 1, and 0 has an output of 4. How is something not? Well, let's look at these examples down here. 3 having an answer of 1 and 2 having an answer of 4, that's fine. They each have their own answer. This is a no here. Notice what happens. 2 has an answer of 4, and then 2 also has an answer of 3. Because it has 2 separate answers, I don't know which one they want. Do they want the 4? Do they want the 3? And that possibility makes it so something is not a function. It's got to be only one possibility. I got to know the answer. I put 2 in, it's 4. 2 and it's, oh wait, it's 3 or 4? I can't have that. Over here it's 2 equals 4 and 3 equals 1. I need to know what the answer is in order for it to be a function. Now there are different ways to represent relations and functions. One is just making a table. Now here's some ordered pairs. There's 5 of them. -2, 1, -2, 3, 0, -3, 1, 4, and 3, 1. Another way we can do this is by also doing a graph. We can graph all these points. -2, 1, so we go over 2 and then up 1. Then -2, 3, 0, 3, 1, 4, and 3, 1. Okay. And then there's a special one called a mapping here in the bottom. Now, what we do with the mapping is we put 2 columns together. We put a column of the domain and a column of the range. So remember when I told you that the domain needs to be in order from least to greatest, and it also can't repeat? Well, look, notice I have 2 -2s. On my domain here, I just put 1 -2. Over here, I have 2 1s, so I only put 1 1 here. Now, what are all these lines? It's like a matching. So what's the first pair? -2, 1. So I go from -2 to 1. Then -2 to 3, 0 to -3, 1 to 4, and 3 to 1. So notice how each and every one of these lines represents an ordered pair. Now we know this is not a function. Again, why is it not a function? Because this x repeats here. We have a -2 equaling to 1 and a -2 equaling to 3. I don't know what the answer is for -2. It's either 1 or 3. So I can't have that. And notice how it looks down here with your mapping. See how -2 branches off? It branches off twice, and I can't have those branches. So when you see something like this for a mapping, you know that it's not a function. And then looking over here, the way that we can tell it on a graph, is let's look at the 2 points that we have a problem with, negative 2, 1 and negative 2, 3. Negative 2, 1 and negative 2, 3. Notice the relationship of these points. They're on top of each other. They're vertical from each other. That causes a problem. That negative 2 has 2 answers. That leads us to what's called the vertical line test. And what we want to do is we want to make a vertical line and should only touch each graph once. This graph over here is a function. This one over here, being the same type of graph, just going in a different direction, is not, because that vertical line touches twice. That value for 1, I don't know if it's up here or down here. And because of that possibility of having 2 different answers, that makes it not a function. All right, let's try some problems. Here's 5 different problems up here. Let's state the domain and range of this relation. So let's start with the domain. We start with all the x values, negative 4, negative 3, 0, 1, 3. Then our range goes from the bottom up, negative 2, 0, 1, 2, 3. Again, that's in order from least to greatest. Is this a function? We're looking for that vertical line. Is there any number that repeats itself? No, I think we're okay. So this is a relation. The relation is there. I can wrote them all out. The domain is listed. The range is listed. And then we, of course, is it a function? Absolutely. So what about this one? We got 4 different points here. The domain is negative 3, 0, 2, 3. Negative 3, 0, 2, 3. Negative 3, 0, 2, 3. So it's not C, it's not A. So it's either B or D. The other thing is just the same, so I'm not worried about that. And one says it is a function, one says it isn't. So I'm going to go back over here. I'm going to look at my points, and I see no points on top of each other, so it is a function. And there's our confirmation. Got 2 other ones here. Here's a table. The domain, again, put it in order, 11, 12, 13, 14. Range, 38, 40, and only 46 on there twice. Is it a function? It is. Everything has an answer. Now, granted, 13 and 14 both have the same answer. That's fine. But they all have one answer. How about over here? This one's a little bit tricky. It's not a relation as such, but we can go ahead and say domain. The domain, this graph, keeps going. It's got arrows going in both directions. So the domain is all the x values. It's using all of them if we continue the line on. But what about the range? It's only going from -1 here up to 1. It's got no values up here and no values down here, so we just say from -1 to 1. Is it a function? Yeah, because there's nothing that repeats. It's a weird function, but it is a function. Another thing that we can talk about is what's called function notation. Now, this is just a special way to do order of operations. They're going to give us they call a rule. Here it's x to the third minus 3. And they want us to find f of -2. Now, I know there's an equal sign here, and you're going to want to put maybe equals -2 and solve it. That's the incorrect way of doing it. All we're doing is taking this -2 and substituting it in, and then just doing an order of operations problem. So even though there's an equals here, we're kind of actually going to ignore it. So here's the original, and as I said, we're putting -2 in. We're putting -2 in there and -2 in there, and then we're just going to forget about this part over here on the left. Now we're just going to solve this. -2 cubed is -8 minus 3, or just -11. And so my answer is just the -11, and I am just looking for that one value. Let's try another one. Here's x squared plus 5. So now we're going to put -1 in there. X squared plus 5, put -1 in there. So -1 squared is +1. +1 plus 5 is 6. So the answer, of course, is just 6. One last one. Here's a little bit longer. We have 2 different x's. Okay, so we're going to put in -3 twice. We're going to put it in for the x squared and the x over here. Notice the parentheses I used just to kind of make sure I have them. So -3 squared is +9. 3 times -3 is -9 plus 2. The 9's cancel, leaving me just 2, and our answer is 2. And that's what I have for you today.